Okay, so here's the example on how to make the graphs. You can use your graphing calculator. I would caution you on that because it's going to graph an output for every single integer valued input. You can see I have the domain and the range from earlier that we already found. The range we said was greater than or equal to because a was positive 2. But what I want to make sure we're clear on is that a tells us also how the graph is stretched or compressed and which way it's going to not necessarily open, but whether or not it's going to be reflected. So you'll see I got two things here in green, and the first one here says that since the starting point is 2, 0, which is dictated by our domain and range, it tells us the graph is going to be 2 units to the right of the parent function, and because it's a positive 2 up here for a, it's going to tell us the graph is stretched. Okay? Now to this table that's sitting here. You'll notice I have the function written in the middle, so down here I could fill in the values I chose for x. Some of you may be wondering why I chose 3, 6, and 11. Well, if I choose a 3, 3 minus 2 gives me 1, and the square root of 1 is 1. If I were to choose a 4, and I'm going to just pencil that in right here, if I have to find the square root of 4 minus 2, then I have to find the square root of 2. The square root of 2 is an irrational number, and irrational numbers are very hard to work with. So we want to try to choose x values that are going to result in our radicand being a perfect square. That's why I did not choose a 4 for x. That's also why I did not choose a 5 for x. Instead, I went to a 6, because when I do 6 minus 2, I get 4. And the square root of 4 is 2. 2 times 2 is 4. I didn't choose 7, 8, 9, or 10 because none of them will allow me to square root a perfect square. But if I choose 11, 11 minus 2 is 9. The square root of 9 is 3. 3 times 2 is 6. Now I have my points, and I can plot them. The point 2, 0 lives right here on the x-axis. The point 3, 2, and you'll notice I intervaled my graph in units of 2. And we have the point 6, 4. And then we have the point 11, 6. So you want to make sure that your graph illustrates that curve. All right. If I'd gone by units of 1, that curve would be a lot easier to illustrate. But it wouldn't fit on my paper. Okay. When you plug this into your graphing calculator, it does a really nice job of showing you the graph. The problem is it shows you the whole graph in that normal screen that we have there on the calculator, and it can be hard to read. But that will also give you your tables, just like it would with quadratics. Okay. Our second example. And you'll notice these are the same ones that were on the first video. So if you didn't watch the first video, that's why this isn't making sense to you yet. Y equals the square root of x plus 3. Notice the only thing inside the radical is the x. So the radicand of this problem is x. The plus 3 is outside of it. All right. Domain says I take the radicand, I set it greater than or equal to 0, and I solve for x. Well, it's already solved for x. The range, because a is positive 1, is greater than or equal to, and then whatever's being added or subtracted outside the radical is what your range is compared to. Now, those two values also indicate our starting point of 0, 3. You'll notice in the table I wrote 0, 3, but there's no math problem written there because I don't need to do a math problem for that one. All right, that information I could glean directly from what I was given. Sometimes you can, sometimes you can't. All right. The starting point, again, tells me how the graph compares to the parent function. Well, this graph has moved 3 up from the parent function, but because a is positive 1, it is not stretched, nor is it compressed. All right. So I'm going to do this table with you, and it should help you guys. You'll notice here I chose an x value of 1, 4, and 9, because when I square root 1 and I put these numbers in, I get nice numbers for my answers. The square root of 1 is 1. 1 plus 3 is 4. The square root of 4 is 2. 2 plus 3 is 5. The square root of 9 is 3. 3 plus 3 is 6. And now I have a very nice function. I'm going to go ahead and I'm going to label the x-axis in 2s, I think. 3, 4, 5, 6, Yeah. I'm going to do the x-axis by 2, and I'm going to do the y-axis by 1s, which is perfectly legal. And it helps my graph fit on my page. Again, your graph needs to fit, guys. Okay, so there's my graph. I have the point 0, 3 is where it starts. So it starts on the y-axis, which means it has a y-intercept of 0, 3 as well. Finding y-intercepts is still the same as it's always been. We put a 0 in for x and we solve the equation. Just like it was for quadratics, just like it was for linear functions. Our second point is 1, 4. So I go to 1, I go up to 4. Our next point is at 4, 5. Remember, I counted by 2's on the x-axis. And our last point that we have here is 9, 6. Now this graph does a nice job of showing the curve. Okay? And there's my graph. All right? If you have a graph that does not make that nice gentle curve like example 1 and example 2 did, then you've done something wrong. Check your order of operations. Most likely that's the issue. Okay? All right, now we're going to go look at example 3. All right, you'll notice I didn't do a whole lot of starting here, so this is going to take a little bit longer. All right? And that's okay. It kind of starts us and walks us through the whole process again, just for a good review. So the radicand in this problem was x minus 4. So you can see I took x minus 4 and I set it greater than or equal to 0. And I'm going to solve that for x by adding 4 to both sides. And I'm going to get a domain of x is greater than or equal to 4. Okay? In this problem, because a was negative 2, that tells me that my range has to be less than or equal to. And the number it gets compared to is this negative 6 out here that's being subtracted from the radical. That tells us our starting point is at positive 4, negative 6. Because a was negative 2, I went ahead and made some notes right here that it's reflected over the x-axis and the graph is stretched. But now that I know my starting point is at 4, negative 6, I also have to add that it is moved 4 to the right and down 6. So this graph actually has 3 transformations when you compare it to a parent function. It is reflected over x because a was negative 2. It is stretched because a was negative 2. And now that the starting point is at 4, negative 6, I have to describe where the starting point is for this function. Now, bear with me because this graph's going to start in a not very nice place. And I'm going to go ahead in this one, and I'm going to use my graphing calculator. Okay? So I'm in the y equals screen, and I'm on y1, and I'm going to enter this function the way it's printed. So I'm going to hit negative 2, and then I'm going to hit second square root. I'm going to enter x minus 4, but then I have to hit the right arrow so that it ends the radical. If I don't hit the right arrow, it's going to put the minus 6 underneath the radical. Okay, and I'll show you that here in the next entry. If I enter the problem and I don't hit the right arrow and I just go right to minus 6, notice how it puts x minus 4 minus 6 all inside the radical? That's not the function that's printed on your page. So you have to make sure that once you're at the end of the radicand, you hit the right arrow on your calculator key. Okay? And we're going to hit graph. And it starts our graph down here in quadrant 4. If you recall, we can get our table because now we go second table, and it shows us our graph. And you'll notice that in the table, every point prior to 4, negative 6 shows an error because there is no output for x values that are less than 4. Your x values cannot start until you get to an x value of 4. All right? So I'm going to take my table for this function right off of my graphing calculator. It makes it a little bit easier on me because there was a lot of math here to do on this one. So I have a table. Here is my x. Here's my y. Scroll down here to get my numbers. I have a 4, -6. That is my starting point. Then I see that I have a 5, -8 with integers, so I can use that value. Then I'm going to go down and try to find the next one. I got an 8, -10. And I'm going to pull a fourth one off my table just to have it. 13, -12. Now, you will notice, my children, that those x values and y values are very large or very small. That's okay. We're going to make them fit on our graph. All right. So we're going to sketch this graph. We know we start down in quadrant number 4. So I'm only going to draw quadrant number 4. I know my x values go up to 13, so I'm going to have to count those out by 2's. And that's okay. And that's just because of where I am on my graph paper. All right. If I was in a different position on my graph paper, I might count them by 1's, but, you know, I might not. My y values start at -6, and I don't think I can fit. I can fit them all on here. So we're going to go ahead and count the y-axis by 1's. So we get a better picture of our graph. All right. I've got my ordered pairs. I've got my graph. My first point is at +4, -6. My second point is at +5, -8. My third point is at +8, -10. And my fourth point is at +13, -12. Okay? So you can see this graph does a really nice job of starting the curve. And there's my curve. Okay? Now, these graphs are going to be different. All right? I encourage you to take your time. If you have a graphing calculator, use it. If you have Desmos, the app downloaded, you're free to use that. I just caution you that when you're entering a radical function, to make sure that you kick it out of square root mode or radical mode before you enter anything that's outside the radical. All right? I will post another video in a little while.